everyone, and welcome back to another episode of Once Upon a Lecture. Today we're going to be diving under the sea to learn all about frequency and frequency distributions. So here are some of the things that we're going to be learning today. The first thing we'll do is start off by talking about what is frequency and understanding the true definition of frequency and frequency distributions. After that, we'll learn how to calculate cumulative frequency in both a raw numerical form as well as in a percentage form. So without further ado, let's get started. So what is frequency? If we think about the definition of the word frequency, all it means is how often something happens. Like, what's the frequency with which a mermaid can meet a handsome prince? What's the frequency with which I can find a new object to add to my collection? Frequency just means how many times or how often something happens. And when we talk about statistics, if we talk about frequency in a particular data set, what that means is that we're trying to see how many times a particular number occurs given a set of data. Typically in the world of statistics, frequency is illustrated using an italicized lowercase f. Let's consider a specific example. Imagine that you are looking at the scores of a scavenger hunt for everyone in King Triton's kingdom. And the higher the number, the more items were found. So let's say this is the data set that we came up with, okay? We have 25 different participants in our scavenger hunt. Everyone from my sister to Flounder to the seahorses. Everyone in the kingdom participated in our scavenger hunt, and here are the scores. As you can see, some did very well in the scavenger hunt, finding 10 items, and some not so well, not even finding one. So our range is from 0 to 10. How many players found 7 items? So what we would do is we would have to look down the column of the score and count how many people found 7 items. Let's try it and see what we get. According to my counting, it looks like only 2 people found 7 items. Is that what you got? So in other words, how many times did the score 7 occur? The number of times the score occurs is the same thing as its frequency. So we could say the frequency of the score 7 is 2 because it happened only 2 times. How many players found 10 items? In other words, what is the frequency with the number 10 occurring? And you can also answer the same question, how many players found less than 5 items? So everything from 0, 1, 2, 3, and 4, right? That would answer the question of how many players found less than 5 items. I calculated that 7 players found less than 5 items. Hopefully that's what you got too. So calculating this would have been easier if we put these numbers in some sort of order. And so typically putting frequency in order is the same thing as calling it a frequency distribution. So that takes us directly into my next topic. What is a frequency distribution? Well, a frequency distribution is a method for describing and organizing data. So the more data points you have, the harder it becomes to calculate it or to classify it or to describe it if it's not in any particular order. So with a frequency distribution, we're going to arrange scores in our data set from highest to lowest, placing the number of times each score occurs in a column beside it. So you may remember what we just learned, that frequency is the number of times a particular score occurs. So again, just as a reminder, frequency typically is illustrated as lowercase f, and the score that we're going to be cataloging is typically illustrated by the letter X. The total number of data points in a data set are typically illustrated by a capital letter N standing for the number of data points. So far, for your frequency distribution, you need a frequency column, an X column for the score, and you need to know that the total number of data points we had were 25. So the first thing we need to do is sort these data in ascending or descending order. Usually we put them in descending order from highest to lowest. If you prefer to put it in ascending order from lowest to highest, you can, but for my example, I'm going to start with the descending order. So this is the data set that we started with. The first thing we want to do, because we're putting it in descending order, is start with the largest number. So you may recall that the largest number we had was 10. So we're going to start with the number 10 at the very top, and then we're going to work our way down. You should get a chart that looks similar to this. So 10 is the highest number, 0 is the lowest number. And then what we want to do is add that F column, right, that frequency column, to show how many times that particular score occurred. So that should give you a chart like this. So the number 10, the score of 10 occurred twice, the score of 9 occurred 5 times, the score of 8 also occurred 5 times, so on and so forth till you get to the very bottom of the score of 0, which only occurred 1 time. So this is an example of a frequency distribution. If you look at the chart, the very first one on the left, that's the one that we started with all of the raw scores. After that, we put them in descending order from the largest score to the lowest score. And the last thing we did is we identified how many times or how often or what the frequency was for each score. Now what we'll do is we'll talk a little bit about cumulative frequency. When you talk about the word cumulative, it means a collection, an aggregate of things. So frequency distributions can also tell us how certain scores compare to other scores in the same data set. And we can also calculate percentage of these frequencies. So I'm going to show you 2 different formulas that we're going to be using in a couple minutes for learning how to calculate the percentages for a regular frequency and a cumulative frequency. So if we do look at the formulas, the formula for the percentage of frequency is equal to the frequency, right, the number of times that score occurs, divided by n, where n represents the number of data points we had in the data set. Do you remember what that was? I think it was 25. Then, once you have that ratio, you're simply going to multiply it by 100 because that's what we do when we try to calculate percent. You're going to do the exact same thing for cumulative percentage frequency. Once we learn how to calculate the cumulative frequency and divide it by n, again 25, and multiplying that by 100. So the process is very similar. The only thing that changes is the numerator. In one instance, you will have the frequency. In the other instance, you will have cumulative frequency. So let's learn how to calculate cumulative frequency. If we try to calculate that cumulative frequency, the first thing we need to know is how many total data points we have. Again, we've mentioned a couple times that this number is 25. If you wanted to calculate it yourself, all you would need to do is add up that F column, add up the frequency column. So if you add 2 plus 5 plus 5 plus 2 plus 3, etc., all the way down, you should get a total of 25. And it looks like that's exactly what we got. So what you want to do is you want to add another column to your currently 2-column view. And what you want to do is start at the very top and subtract the frequency of each data point from the total. I know that was a mouthful, so let's do it together. This is what I meant when I said go ahead and create another column and label it CumF. CumF, again, stands for cumulative frequency, and in parentheses I've written that we will be doing this in descending order. So you should have the score from the scavenger hunt, the frequency with which each score occurred, and now our new column, CumF. The first thing we want to do is find out what was the total sample size, the total number of data points, which we know is 25. So you're going to go ahead and put 25 in that first line. From here, what you're going to do is you're going to subtract each frequency from the total. So if our total frequency is 25, 25 minus 2 will give us 23. So all I've done is I've taken the 25 total and I've subtracted 2, which is the frequency in the first line. From there, I get 23. The number of frequency that I need to subtract from 23 is 5. So all you're doing is going straight down the line. 23 minus 5 gives us 18. I'm going to continue. 18 minus 5 is going to give me 13. 13 minus, now I have the number 2 here, is going to give me 11. 11 minus 3 is going to give me 8. So eventually, once you complete your chart, this is what it should look like. If this seems confusing, sometimes drawing a little path may be helpful. So basically, all I'm doing is I'm subtracting as I'm going to the left, putting the new value in the box to the right, and then continuing to subtract and put the new value in until you get to the very, very bottom, and you are left with the number 1. And so the number 1 is the number of people who scored 0 on the scavenger hunt. So I often get the question, Princess Ariel, can I do this in ascending order using addition instead of subtraction? The answer is sure you can, and you should get the same exact results. So if you don't want to start at 25 and subtract, you can start at the number 1 at the bottom and just add the number on the right to the number on the left and put in the new value in the cum F column. So you still have this similar zigzag pattern, but instead of working your way down, you are now working your way up using addition instead of subtraction. I personally like to use subtraction, but if it makes more sense to you to use addition, that's totally fine with me, just as long as you don't get your numbers mixed up. So now that we've learned to calculate cumulative frequency, what we're going to do is learn how to calculate the percentages that go with these values for frequency. So let's start with percentage frequency first. The whole purpose of calculating percentages is for us to be able to compare to other data points within the same data set. So oftentimes when we're describing a particular data set, we like to use percentages. We like to say what percentage made up, a group of people who scored less than 10 on this scavenger hunt, etc. So percentages are used to describe a data set, but they are not used to make any sort of inferences. If you watched Princess Jasmine's video on the introduction to statistics, you'll remember that she told you about the 2 different branches of statistics, the first being descriptive and the second being inferential. Descriptive statistics are used to do just that, describe a particular data set, but inferential statistics are used to make inferences on larger populations based on your results from a particular sample. So in this case, just reminding you that percentages are used as a descriptive statistic and are not used to make any sort of general inference for a larger population. But percentages do help us evaluate and describe a particular data set more easily. So now that you've learned how to calculate the frequency and cumulative frequency, we're going to find the percentage of these frequencies relative to the data. Let's start with the first one, percentage frequency. What we're doing is we're converting the raw score, the frequency number, into a percentage, which is going to be reflective of that same number, but in percentage form. So the formula is frequency divided by n, where n is the total sample size, and in our case, that's 25. And we're going to multiply that by 100 to get the decimal to move into a percent. So the first thing we're going to do is create another column, and you're going to label this column %F. So here, as what you see in the slide, the first 2 columns are the information that you've already calculated. If you notice, I have left off the cumulative frequency column just so that it will be easier for us to see which numbers get plugged into the formula. But by all means, you can keep working within the same document. If you have your cum F column, you can put the percentage frequency right beside it. All right, so after we have our column and we've labeled it and we are familiar with our formula, what we're going to do is calculate this percentage. So the first thing we're going to do is we're going to take the frequency in the right column. So we'll start with 2 because that's the first one we have. Make sure you don't make the mistake and put in the number from the score itself. What we're interested in is the number of times the score occurred, not the score itself. So the frequency that the number 10 occurred is 2. 2 represents the number in the F column. If you take 2 and you divide it by n, that means you will be dividing it by 25, since we had 25 total people in our data set. Once you do 2 divided by 25, you're going to go ahead and multiply that by 100 and see what you get. Once you complete that, go ahead and try the next one. So the next one is the score of 9. Remember, we don't care about the score, we care about the frequency with which it occurred. So the score of 9 occurred 5 times. So the F value is going to be 5. You're going to divide 5 by 25, because that's the total number of people in our sample, and multiply that by 100. So go ahead and try to do that, try to calculate that, and you should end up with this type of column. So we have 8% for the first one, 20% for the second and third. So ultimately that means that 2 is 8% of 25. 2 out of 25 people represents 8% who scored a score of 10. So you can answer the question, how many people scored a 10? The answer would be 2. But you can also ask, what percentage of the data set scored a 10 on the scavenger hunt? And you could say 8%. So this is what I meant by percentages allow us to answer different types of questions related to the same data set. So now that we've calculated percentage frequency, we're going to calculate cumulative percentage frequency. So remember you had that CumF column that we recently calculated together? We're now going to use that number and put it into the numerator, divide it by 25, and multiply by 100 once again. So now that you have your percent frequency column, you can go ahead and put that cumulative frequency column right beside it, and you need one last column called percent CumF. So percent cumulative frequency. In this column, you're going to do exactly what you did with the frequency, but now plug in the number from the CumF column. So looking at the first line of the CumF column, you have 25. 25 divided by n, which in this case is also 25, multiplied by 100 gives you 100%, because 25 out of 25 gives you 100. Does this make sense? Absolutely, because now we're talking about cumulative percent. Altogether, in aggregate, if 25 people out of 25 people scored 10 or less, that would give you 100% value. So let's go to the second line. 23, CumF of 23 divided by 25 multiplied by 100. So basically that means how many people scored less than 10 on the scavenger hunt, because 23 out of the 25 were in fact that group of the population. So if you complete your calculations, these are similar to the results that you should have. So again, the most should always be 100%, because that represents everyone in your data set. 92% of our data set scored less than 10 on the scavenger hunt. Let's say we want to see how many participants of our game scored 5 on the scavenger hunt. So we're going to go look at 5. And so we see that 4% of our data set scored a 5. But if you move your finger over to the cumulative frequency percentage, you will see that 32% have scored 5 or less. So when you're looking at the percentage frequency, it's telling you the percentage for that specific number. But when you're looking at cumulative percentage, it tells you everything at that number and below. So again, cumulative means the more as things get added. So whether you're looking up or you're looking down in the cumulative frequency column, those will be the numbers that are relative to the number that you're looking at and all the numbers below it. So by looking at this chart, we can ask 2 different questions. We can say, how many players scored a 6 on the scavenger hunt? We can see that 3 players scored a 6. If we ask what percentage of players scored a 6 in this data set on the scavenger hunt, we can see that 12% of the data set scored a 6 on the scavenger hunt. However, if I'm curious to know how many people from the entire data set scored 6 and below, I would be using the cumulative frequency column, and I can see that 11 players scored at least a 6 or below. And furthermore, if I wanted to see the percentage of players who've scored a 6 or below, then I would look in the cumulative percentage frequency column, and I would see that that is 44% of players scored score of 6 or below on the scavenger hunt. So again, using percentage frequency, cumulative percentage frequency, and even a regular frequency distribution, you are able to answer so many questions about a particular data set that would have been much more difficult to answer had we not put them in this distribution. So let's recap what we learned so far. We learned about frequency distributions. We understood that frequency means how often or how many times a particular score occurs. So when interpreting data sets, it's often really helpful to organize the data into a frequency distribution so that we can see the data points in ascending or descending order. We also learned how to calculate percentages for individual frequencies as well as cumulative frequencies. So here's one final look at the chart that we've come up with today. Great job, guys. I hope that this was helpful in helping you understand how to construct frequency distributions. Thank you so much for tuning in to Once Upon a Lecture, and I hope that you can catch my friend Princess Elsa on the next episode as she tells you about graphing data in statistics.